Hello, welcome to the lecture on 4-axis wrap cam strategies. I'm Todd Frazee with Sierra College. This lesson focuses on the wrap feature available in some 2D cam strategies in Fusion through the multi-axis tab, designed for machining features on cylindrical parts. The wrap feature allows you to wrap the toolpath around a cylindrical shape, enabling the precise machining of features along the surface of round parts. In this lesson, we'll explore the option that is present in several Fusion manufacturer mode commands. The strategy typically generates full 4-axis machining, but can be applied to more complex machines with specific constraints. The objectives of this lesson is by the end of this lesson, you'll be able to apply Fusion multi-axis tab cam wrap strategies to machine wrapped around cylinder features in 4th axis setups, model cam and 5-axis CNC mill applications to industry standards, and apply cam and 5-axis CNC mill applications to industry standards with the activities that are coupled with this lecture. Cam strategies that include the toolpath option under 3-axis are 2D adaptive, 2D pocket, the 2D contour, the slot, and engrave commands. So all 5 of these commands can be wrapped around a cylinder using the wrap function. The wrap toolpath option adds a 4-axis rotary contouring toolpath to the command that's selected. That's normally a 2D strategy. The option analyzes the selected chain and keeps the tool normal to the selected center around the center of rotation of a single rotary axis. It's important to note that you do have to have a 4th axis for this command to function, and we'll be outputting either A, B, or C codes telling the rotary to spin. And these rotary axes are full 4-axis moves, so all axes can move simultaneously with this command. And the wrap option is found in the multi-axis tab for relevant commands. This has recently moved, and it was formerly in the geometry tab. You simply switch from the 3-axis icon to highlighting the wrap icon, which is shown in blue on the right. And you need to select the cylinder you want to wrap around it, and it will automatically bring in the radius of that wrapped cylinder. And you can put in an offset from that cylinder if you choose to. Again, you do have to have a 4th axis rotary, and the cylinder does need to be spinning around the center of rotation of the rotary axis for this particular function to operate properly. Okay, so let's look at a demonstration of how this tool works. We're going to import one of the training videos. This is a prismatic mostly part that has 3+1 and full 4-axis wrap features on it. Couple commands using the wrap command. There's a sample file, and if you go to your data panel and go into cam samples. So here it says cam samples. And we're going to scroll down, and you're going to open the 4-axis index, wrap, and patterns. And it should have Haas rotary rotary table with a sample part. Now they've already programmed this to follow along with a different tutorial, but what I'm going to do is we're going to go through and do this, just the wrap features on here. The indexed features are in one folder, and then the purpose of this tutorial, the software's changed since their tutorial was released, so hopefully this is more current. Okay, let's go ahead and minimize the data panel. And initially you need to set up the stock origin a little bit different than what they had in the sample. So pick on rotary setup. And they had the orientation of the spindle and the x-axis backwards, so I'm not sure why that was, but go in here and orientate your spindle with the neutral position with Z normal to the table and X pointing to the right. So you would just use the work coordinate system face for Z. You can pick on the table, that'll snap it up, and then you might have to flip the X-axis to have it pointing in the correct direction. Alright, our stock volume, it's already set up, but they set it up as from solid, so the solid model is your stock for this operation. In a prior op they had it looks like a rectangular box. The main thing with wrap is it has to be fourth axis and it has to be on center line of whatever it's rotating. Otherwise it won't output correctly. So for these fourth axis commands, make sure that whenever you're setting your origin, it has to be on rotation of center, okay, for your neutral position. So in this case, we're rotating about the x-axis, or it's an a-axis. All right, next, what we're going to do is we're going to create an adaptive, let's go ahead and hit OK on this. So make sure your origin looks like what I have there. And we're going to create, under the root folder, we're going to ignore what's already in here. And we're going to create first an adaptive clearing for each of these two, basically two pattern pockets that repeat themselves as they rotate around the model. Okay, we're going to do 2D adaptive clearing. Wow, 12,000 RPM, they got a fast spindle. Anyway, it's using an existing 1/4 inch tool. For the purposes of this demo, we're just going to leave it as alone. We don't have 12,000 RPM. Our machine will only run up to 8,100, but that isn't relevant. So the main thing we're doing is we're going to this multi-axis tab, and we're going to select the wrap option, and it opens up these other options here, and you can pick unwrap geometry. You can wrap the cylinder, you can do an offset from it, and a radius. And so we're going to pick the cylinder of the floor of our first pocket, and that is our face. We're not going to put any offsets in. You notice it put in the radius. Okay, and then our geometry, what we're actually going to cut, is going to be that same pocket. Interesting. Okay, so you want it on the outside of the profile there. Alright, we're going to leave most of this other settings to default, and okay, and there we go. We got kind of a conical conical plunge, but you see how the toolpath follows the surface of our contour and wrapped, and then our walls will have draft on them at the angle which the end mill is normal to the surface at any given moment. Alright, let's do one more. Let's do a 2D pocket. We'll go ahead and leave all this at default. We're going to go back to our pockets tab. We're going to pick the wrap command, and the cylinder we're going to wrap is the same feature. And then on our geometry tab, bottom of the pocket, hit OK. Okay, then here we have our pocket geometry. Not sure why, but I was having a lot of delay in the time and processing. So we've now, pocketed out this feature, and it'll follow 5-axis wrap. Now we're going to do this next pocket here. So we'll just go ahead and duplicate our tool path. We'll move the adaptive up so it does both roughing cuts. At the same instance, we're going to go edit. We'll do multi-axis, make sure we're on wrap. We're going to select the other face, although the cylinder diameter may be the same, so it may not matter. And then we're going to go to geometry, and we're going to select the chain of the other pocket and delete the first one. I'll leave everything else at default. Now, because this is a round shape and it's a rotary, your retract planes are actually circles. So this works the same way. You've got your rapid motion going from the orange to the retract plane, clearance plane, and then it's going to feed in and then retract. You do want to make sure that this is far enough out. You might, depending on the rotary, you might need to actually have the rapid plane bigger than the rotary. Okay, so let's go and hit OK. Okay, so there we have our second adaptive. And then we're going to go and create our pocket. Do the same thing here. We're going to duplicate, edit. We'll go to multi-axis, make sure we're on wrap. We're going to delete the face we were referencing. We're going to select the new face. Then we go to geometry, and we're going to delete the existing chain and select the new one. And then we'll go OK. And we've got our new pocket here. Now let's simulate these so you can see what's happening. Okay, so we're going to come in, and that's pretty excessive distance on the helical plunge. I would probably reduce that closer to the part. And then it's moving and rotating the fifth axis and pulling out for the roughing. Same thing there, and then let's simulate the pocket. There you go, simple enough. The next lesson, one of the next lessons will show you how to use the pattern command, where you can take this wrapped features, these two wrapped features, and then pattern them so that you don't have to program each face. Okay, I hope that demonstration was fruitful for you. In summary, in this lesson, we focused on the wrap feature available in some 2D CAM strategies in Fusion through the multi-axis tab, which was designed for machining features on cylindrical parts. The wrap feature allows you to wrap toolpath around a cylindrical shape, enabling the precise machining of features along the surface of round parts. In this lesson, we explored the option available for the following Fusion manufacture mode commands: 2D adaptive, 2D pocket, 2D contour, slot, and engrave. The strategy typically generates full 4-axis machining, but can be applied to more complex machines with specific constraints. And those constraints are that you do have to apply it on the center line of one of the axes of rotation. So if you have a full 5-axis machine, it will do it, but the feature has to be aligned to the center of rotation of one of your 2 rotary axes. In conclusion, in this lesson, you were able to apply Fusion multi-axis tab to apply the cam wrap strategies to machine wrapped around cylinder features in a 4-axis setup. You also model cam in 5-axis CNC mill applications to industry standards, and apply cam to 5-axis CNC mill applications to industry standards. This concludes this lecture. I hope it was helpful for you.